I know, I love cars.
Huh, I wonder how all this velocity stuff has to do with math.
You know what? I think that's explained in the calculus book in chapter 3.
Chapter 3?
Yeah. Hey, I just read about velocity and rates of change.
Oh, hey, I think I read about that earlier. You have your function, which is the position, and the derivative of the position is your velocity, and the derivative of your velocity is your acceleration. Velocity is when you're going faster and moving position, and acceleration is when you go faster going faster, like when you speed up in your car.
Oh, can you do an example of that?
Hey, let's go do one! All right, so the first problem we're going to do today is particle motion, all right? So our problem says, a particle moves along the line so that its position at any time t greater than or equal to 0 is given by the function s of t equals t squared minus 3t plus 2. So the first thing we want to do is write down our problem. T plus 2. Okay, so the first question they're asking for is find the displacement during the first 5 seconds. So because this is our position function and we're trying to find the displacement in 5 seconds, we simply plug in t equals 5 into the problem. So we have s of 5 is equal to 5 squared minus 3 times 5 plus 2. So, working out the rest of the problem, we have 25 minus 15 plus 2, and we get 10 plus 2, which is 12. So that's our answer for number A, problem A. Now, the second part of the question asks for the average velocity during the first 5 seconds. Now, because they're asking for the average velocity, we need to find our velocity equation. Now, the velocity is the derivative of the position function. Therefore, the derivative of the position function is equal to the velocity. So, we need to derive this equation. Therefore, we take the derivative of both sides to find the velocity, and we get the derivative of t squared, which is equal to 2t, minus the derivative of 3t, which is 3, plus the derivative of 2, which is 0. So this is our velocity equation. Now we'll go back to the problem and see exactly what they want. Find the average velocity during the first 5 seconds. Now, in order to find the average, we need to find the velocity at the end, and then the velocity at the beginning, and subtract them over the interval of time. So basically, we need to find the velocity at the end of 5 seconds. So this time we plug in 5 to our velocity equation to get the velocity at the end of 5 seconds. And we get 10 minus 3 is equal to 7. So this is our ending velocity. Now we need to find our starting velocity. Our starting velocity will be at 0 seconds. So, at 0 seconds, we have a velocity of -3. Therefore, we take the ending velocity, 7, minus the beginning velocity, which is 3, over the interval of time, which is 5 seconds. Therefore, we get 10 divided by 5 equals 2. So the average velocity of the interval over a 5-second period is 2.
All these rules for derivatives, there's so many. There's the product rule, the quotient rule,
And finding the derivatives of trigonomic functions, logarithmic, exponential.
and don't forget the chain rule.
Oh, the chain rule! Chain rule! Alright, so for the chain rule, what we're going to do is first we take the derivative of the outside, and then we take the derivative of the inside. So, dy dx is equal to the derivative of sine, which is cosine, of same inside, 7 minus 5x, times the derivative of the inside. 7 minus 5x would be negative 5. Therefore, the derivative of this equation is negative 5 cosine of 7 minus 5x. Now that wasn't so hard.
Shannon, wake up.
What?
What's with all these y's in this problem?
Oh, I know how to do that. All you need is...
implicit differentiation. Now, for this problem, we're going to start with x squared times y plus x, y squared equals 6. Now you may look at this problem and think, how can I differentiate this? Implicit differentiation is your answer. So we're going to differentiate the entire equation. So, using the product rule, we differentiate x squared first. So, doing this, we get 2x times y plus x squared times y differentiated. So, when we take the derivative of y, we get dy in respect to x, which is dy dx. So that's our first side of the equation. Next, we differentiate x times y squared. Therefore, we get the derivative of x, which is 1, times y squared, plus x times the derivative of y squared, which is 2y times y differentiated in respect to x. So again, we have dy dx. And this entire equation is equal to the derivative of 6. The derivative of a constant is 0. Now, the rest of this is simple algebra. You're looking for dy dx. So all we have to do is rearrange the equation to find dy dx. So therefore we have x squared dy dx plus 2xy dy dx is equal to negative 2xy minus y squared. Then we take dy dx and we substitute it out of this side of the equation. So we get times x squared plus 2xy equals negative 2xy minus y squared. Now, if we divide this entire thing by both sides of the equation, we get dy dx equals 2xy minus y squared over x squared minus 2xy. And that's your derivative. And now you know how to use implicit differentiation.
Gosh, chapter 3 is so interesting.
Totally.
Oh, hey,